Hello stargazers, I'm Heath, the Astro Tour Guide. Welcome to my show. We've talked about equipment, we've talked about how to set it up. Tonight we're going stargazing. We're going to see the Orion Nebula through a telescope. Are you ready? Let's get started. Okay, so tonight we're going stargazing, and we've talked about equipment, but the one piece that I haven't talked about yet is actually one of the best ones for getting started, and that's some basic binoculars. They don't have to be huge, big ones like these Celestron 15x70s. Anything that you've got laying around the house will work great. So even if you don't have a telescope, you can go out and do some stargazing. The things we're going to talk about tonight, almost all of them you can spot in basic binoculars. If you go and find what you have laying around the house, something like these Nikon 8x42s will be perfectly fine. I've seen all the things that we're going to talk about tonight in these little basic binoculars. And I really like these Nikon Aculons for just some good carry around, have around the house binoculars. They're good for sporting events, bird watching, you name it. But if you are thinking about buying some specifically for astronomy, I cannot recommend highly enough the Celestron SkyMaster 15x70s. They're only $65 on Amazon, and they are a great bargain. They give a 15 magnification, and they have these giant 70mm lenses to pull in tons of light to your eyes. They really find some cool faint stuff, and they're great. The one thing about them, though, is unlike your common household binoculars, with an 8 magnification. Anytime you get over a 10 magnification in your binoculars, you're probably going to need a tripod because they're going to be wobbly when you're looking through them without the tripod. And so that's another piece of advice that I will give you in choosing a tripod. A lot of people just get their basic camera tripod, and you can do that, but what happens is when you're trying to point these things straight up, on a basic camera tripod, I'm going to unscrew these so I can show you. The basic camera tripod will turn the binoculars straight up, right up next to the pole. And so on the ball mount, you can't really get your face comfortably into the eyepieces because you'd have to kiss the tripod pole. And unless you really love your tripod, you probably don't want to do that. But I found this tripod on Amazon. Again, it's Amazon Basics, but what's cool about it is it came with this neat pistol grip. And aside from being sexy and cool, when you squeeze it, it pulls back, and you'll notice that it's got all this space to where it pulls the binoculars back away from the tripod. So even if you already have some binoculars, I would really recommend this tripod to use with them if you want something to put them on, because it pulls them back far enough that you can get underneath the eyepieces and you're not eating the tripod pole, so to speak. And so it lets you adjust it so that you can look straight up and look all around. This is 72 inches tall. I've got it squatted down so that it fits in the frame here, but I can actually pull it up, and so I can look almost straight up without having to bend back, and I'm 6 feet tall. So a really good tripod. So $65 for the binoculars. This tripod, I think it's gone up a little bit. I paid like $60, but I think it's like $79 now on Amazon. So for, $140, you can get a really good basic astronomical setup, and these things come in really handy. Okay, enough talking about equipment. Let's go out and stargaze. I am so excited tonight because we're going to look at one of my favorite things in the night sky, the Orion Nebula, through a telescope. When you go outside, I've got this set up for tonight, leap year, February 29th of 2020 at about 8 o'clock, which is typically when a lot of people go out. And I'm using a software called Stellarium. You can get that at stellarium.org. I'll put a link down in the description below. This is free software, and it works on Windows or Mac, so whatever you have, you can use this. And it's really good desktop software for planning out what you're going to go see on a given night. And it's also great for learning the constellations and learning the night sky. So when we go out tonight, the first thing that you're probably going to notice when you walk out, if you look to the west, right where the sun was setting, you're going to see a really bright star. And once you get your telescope set up and polar aligned if need be, check it out, because that is not a star at all. What it is the planet Venus. So if you pop your telescope on it, what you'll see when you check out Venus is Unfortunately, it doesn't have a lot of cool colors or bands like Jupiter or Saturn. But what it does have is phases like the moon, because it's between us and the sun, just like our moon when we see it illuminated. It has phases. And so you'll see that creamy white disk covered with lots of cool stuff like sulfuric acid. And you'll see the phases. So check it out. It looks like it's at about a quarter phase right now, similar to our moon. And the other thing to note about it is that if you start watching this, checking it out every couple of weeks, its size changes tremendously. As it goes around the sun and it gets closer and further away from the Earth, you'll see a dramatic change in its size, which is kind of cool to track. So that's an interesting thing to see about Venus. The next thing that we'll want to check out when we first get out is the moon. And you've probably already checked out the moon through your telescope, but one of the things that a lot of beginners do is they think of and go and view the moon when it's full. You walk out, you see a full moon, you're like, oh, this will be a great night to get out my telescope. But that's actually the worst time to check out the moon. The moon is washed out and all flat, and there's no shadows on it when it's full. So if you go out tonight, the moon is about 6 days old. It's almost at its quarter phase. And what is a great way to check it out is to look along the shadow called the terminator, and you can see the mountains and all the shadows that are cast by those mountains across it. It's very sharp and contrasty, and really shows the features off a lot better. The craters show up better and everything along the terminator. Even on this picture, it doesn't do it justice, because this picture is basically just casting a shadow over a picture of the full moon. So it's kind of washed out even on here. So go check that out, and you'll see why that the best time to check out the moon is when it's through its phases and not when it's full. Now, we are ready to actually go and see some deep sky objects in the sky. The first thing we need to do to find the Orion Nebula is to be able to find the constellation Orion. So if you go out and look to the south, or just to the left of the moon and Venus this evening, if you're out early at 8 o'clock or so, notice that there's a really bright star in the sky. This is Sirius. It's the brightest star in the entire night sky. And just to the right of Sirius, you will see 3 bright stars in a row. That is the belt of Orion, and this actually makes up the entire constellation of Orion. I'll light up the lines of it for you so that you can see what we're talking about here. So this is the constellation Orion and what it looks like. And usually this belt is the first thing that jumps out at people, and then you'll see this trapezoid that forms his body. So this is Betelgeuse, his right shoulder. His head are these faint little stars here, Mesa, and Bellatrix is his left shoulder. This is Rigel, his left foot, and his right foot is Saiph. So again, this is the shape of Orion. This is his little shield, or his skin that I think he's holding up in the picture on this one. Let's see what the picture shows. So, and he's holding a club up. This is actually Taurus, the bull, to the right here. And so he's fighting off the bull. So that's what we're going to be looking for in our night sky tonight, is Orion. Now, once you've found Orion, what you want to do is find his belt, and then right below his belt are 3 stars. And in most skies, you should be able to see those even with light pollution. For my backyard, in pretty moderate light pollution, I can still pick these out. And you want to I'm going to turn on my Telrad finder. If you have a Telrad, then use your bullseye. If you have a red dot finder, then put the red dot on it. Or if you have a finder scope with a crosshair, take that and line it up on the middle of those 3 stars in Orion's sword. And when you get that lined up, and then look in your telescope eyepiece, wow, look at that, the Orion Nebula. The Orion Nebula is like looking back in time. This is 1,344 light years away. So when the light you're seeing left that cloud, it was 1,344 years ago. That's 600 AD. In the 600 to 700 times, we were in the Dark Ages in Europe. The Tang Dynasty had just started in China, And the elders of Mecca had run Muhammad out of town. He had to flee Mecca to Medina. So this is a long time ago, this light that you're seeing. We're actually traveling back in time when we look at this. So a nebula is a cloud of gas. This cloud of hydrogen and oxygen and sulfur and other gases is about 20 to 40 light years across. In our telescope and in our sky, it takes up about 65 arc minutes of space. And we measure things by how big they are in arc minutes so that we can know how big what we're looking for is going to appear in the sky. And what's interesting is the full moon is 30 minutes across, but the entire span of this nebula is actually 2 full moons across. The Orion Nebula is really big, and it shows up really nice, even in small binoculars. So no matter what you've got, go take a look at it tonight. This cloud of gas, as I mentioned, is called a stellar nursery. And that's because all this gas has started to pull together in places, and the gravity is forming clumps. And as those clumps of gas get bigger and bigger, they get more gravity and pull in more and more gas until finally you have a giant ball of gas that its gravity squeezes it so hard and gets it so hot that it starts fusing that hydrogen into helium. And once that fusion happens, it starts to explode and lights off and becomes a star. And we have actually spotted within this some tiny protoplanetary disks where stars have just formed and all the dust is still swirling around and will be formed into planets. We call that those proplyds. The Hubble telescope has spotted about 30 of these proplyds, and using the Atacama Large Millimeter Array radio telescope down in Chile, they've spotted over 100 of these proplyds and protoplanetary disks. So this is a fascinating area of the sky, which is really close to us. It makes it great for us to be able to study how stars are formed in stellar formation. Within the middle of this, you will find 4 stars in a beginner's telescope shaped in a little trapezoid that's so famous we've given it a name. It's called the trapezium. And the trapezium actually has about 9 stars, but it takes a really big telescope to see all 9 of them. But this is a good challenge to see how clear the scene is and to test the optics of your personal telescope. See how many that you can spot. I'm going to show you a picture here. The main 4 stars that were first spotted by Galileo and should be visible in pretty much any decent beginner telescope are the A, B, C, and D stars. But there's also an E and an F star that in clear nights with good seeing in a telescope of about 4 to 5 inches or bigger, you should be able to resolve on nights of good seeing. So check that out and let me know in the comments if you see the E and the F star. The G and the H is a binary, so there's 2 to it. And I didn't even mark those on my little chart here that I'm showing you because they're so small that it really takes a big telescope. If you've got a telescope big enough to see those, you're probably not going to be watching my videos to learn how to find the Orion Nebula. Now, the stars of the trapezium are baby stars. They're only about 10,000 to 300,000 years old. And 300,000 sounds like a lot, but in stellar time, that is nothing. Our sun is a middle-aged star, and it's 4.5 billion years old. The oldest star in this trapezium cluster, we're guessing, is about 300,000 years old. The species of man, Homo sapiens, are 350,000 years old. So when first men were walking the earth and they looked up in this part of the sky, they didn't see anything. It was dark. These stars hadn't even formed yet. That's how new they are. So take your time, check out the Orion Nebula, and let me know what you think. One thing, a good way to learn to view is to look at the shape that you see in this picture and then take your time and stare through your telescope and see how much of these edges and these filaments that you're able to see. If you really look at the dark parts and try to see where it turns from dark to light gray, you'll be surprised at how much of this area that you'll actually be able to eke out when you start looking a little closer. Okay, now that we found the Orion Nebula, there's actually some really cool stuff right in the general area. So tonight's tour, we're going to sample some of the different types of deep sky objects that we can see. So the first thing we're going to do is get back to our finder scope, and we're going to find the belt of Orion. And we're going to find this little star right down below the bottom left star in his belt. This is Sigma Orionis. And we're going to use that as a pointer. So we're going to line it up with Alnitak, the bottom left star, and we're going to count this distance from Sigma to that star. We're going to look at about 3 times that. So I'm just going to visually go, okay, that's about how far they are. We're going to go 1, 2, 3. And I'm going to try to put my pointer right about there in the sky. And then we'll go back to our telescope and see what we see. And lo and behold, there's another nebula. This is M78, Messier 78. And it's a nebula, much like the Orion Nebula. The difference is that the Great Orion Nebula, M42, is an emission nebula. The way that it lights up are the stars in the trapezia, and particularly the C star, is shedding out so much energy and heat that it excites the particles of the oxygen and the hydrogen and helium, and they start to fluoresce. Just like in a fluorescent light bulb, the gas in your fluorescent light bulbs, we heat it up with electricity or we energize it and make it fluoresce, and it shines. That's what's happening in the gases in M42 that we just looked at, the Great Orion Nebula. What's different about M78 is this is a reflection nebula. These gases are actually just sitting there like the clouds in our sky, and the lights from our lights shine up at night, and you can look up and see a cloud in the sky. It's reflecting the light from the ground. That's what's happening here. The stars that are behind these clouds are actually just lighting them up for us, and they're reflecting the light off the stars. So this is a reflection nebula, and generally reflection nebulae are very faint. This one is much fainter than the Orion Nebula that we just looked at, but it's one of the brighter reflection nebulae in the sky. So it's a good one to check out. This is again a photographic image. It's not going to be near this bright in your telescope. It's going to be a faint little gray patch, and probably 2 little patches about here and about here. But like we talked about, if you use your finder scope and put it about 3 distances up, then right there is centered on where it is, because I just centered it in our eyepiece. So it's right about there off the belt. And that's about 3 distances if you line up Sigma from Alnitak. Now, what's interesting about M78, aside from being a reflection nebula, it's about 3 light years across. And this one is going to be about 6 by 8 arc minutes across. So where the Orion Nebula is about 60 minutes across, this one's going to be about 1/10 of that size. It's about 6 minutes across. It's going to be a tiny little spot, but it's good to start keeping in mind about how big the things are that you're looking for, because as we start looking for new things, we can see how big they are and know what to expect when we pull them up in our eyepiece. So in a 25 millimeter eyepiece, it's going to take up about that much of your eyepiece in the Meade Polaris 130. This is also a stellar nursery. There are 2 stars that should be visible in one of the 2 little patches of nebula. Infrared studies have shown that there's about 190 to 200 stars being formed within this nebula. So take some time. Let me know if you were able to spot that one. It is a little bit fainter than M42, but I'll be curious to know from these which ones that you guys were able to see and which ones gave you trouble. After we found the Great Orion Nebula in M78, let's go for a globular cluster. The next target that we're going to search for is called M79, Messier 79, and it is right below Orion. So we spot the constellation of Orion, and we can see the belt and the trapezoid. Just below that is much fainter 4-star little trapezoid down here. It's almost like the cup of the Big Dipper over in the northern sky, but it's much fainter. But these 2 stars in particular should jump out at you. This is the constellation of Lepus. Lepus is actually a rabbit. I'll light him up here, and you can see his little rabbit ears. And apparently people in ancient times didn't know how to draw animals, because both the bear in Ursa Major and Lepus have this giant tail. I wonder how they drew the picture here. Did they give him a big tail? Oh no, they've got him running, so maybe that's not his tail. But either way, Lepus is a rabbit, and we're going to use these 4 stars from his little trapezoid to spot where to look. And what's interesting about this is both of these kind of point to an area. And if you come down, particularly if you follow the two brighter ones down, about the distance that they are. So we're going to say about right there. We'll use our finder scope, and that's where we're going to aim for. We're going to come right down about the same distance as these to about there. Put your finder scope about there, and then again look through your telescope, and you should see a faint little splotchy thing. And that faint little splotchy thing is actually M79. Let's zoom in on it. It is a globular cluster. And on the screen, this picture is very unimpressive. It's just a little blob. In a telescope, these globular clusters are fascinating. They kind of sparkle like diamonds. There's so many stars in them that it's hard to resolve them all. The bigger your telescope, the more of them that you will be able to resolve. This globular cluster is 40,000 light years away. So we are really looking back in time when we look at this thing. And globular clusters are fascinating because they're made from some of the oldest stars in our solar system. They're extremely old stars formed a long time ago. So a really fascinating thing about M79, this globular cluster in particular, is that globular clusters are typically associated with the center of a galaxy. They form a halo around the core, around the ball that's right in the middle of a galaxy. But this globular cluster is further away from the center of the galaxy than we are, and we're actually on the outside of the Milky Way. And so what's this little guy doing out here? Well, recent studies have found that there's an actual dwarf galaxy, the Canis Major dwarf galaxy, that we think merged with the Milky Way. And when we captured that galaxy and then intertwined and intermingled with ours, this was one of its globulars that was in its cluster, and we captured it. So this is our little stolen treasure from the Canis Major dwarf galaxy that we stole. So take a look at M79. It's way cooler in the telescope than it is on this planetarium software. Let me know in the comments what you thought about it and how you liked seeing your first globular cluster. So we've seen two nebulae and we found a globular cluster. Where do we go next? Well, now let's go see an open star cluster. And where we're going to go now is over into the Canis Major constellation, which is right over here. We're going to find Sirius, the brightest star in the sky. It's easy to spot. And Sirius is part of Canis Major. That's why they call it the dog star, if you ever wondered or had heard that phrase. And you can see that the stars within Sirius actually form the shape of a dog. There's his head, and his tail, and his legs. So we're going to come over to Sirius, and specifically what we're going to look for in Canis Major is from Sirius down, following his back, there's a bright star that makes it, but there's this second one that's almost as bright, and you can spot it pretty easily. Now, if we take that line from that star and we form a real shallow triangle and go about a third of the way away from Sirius, so about right here, that's where I want you to put your finder scope. So make this line and think of just a little shallow triangle and put your finder scope right about there, and then look through your telescope, and shazam, you will see the cluster M41. It's also known as the Little Beehive cluster. This is an open cluster of much newer stars than the globular cluster M79. So open clusters are a cluster of stars that formed at about the same time and are still gravitationally bound and hanging out together. They form some really cool patterns. This one just has hundreds and hundreds of stars. It's approximately 2,300 light years away, and actually it's got about 100 stars, and it's about 25, 26 light years across. This thing is easily visible in binoculars, and an interesting thing about M41, it is thought that this may have been seen by the naked eye from Aristotle. He makes mention of a fuzzy patch in the thigh of the dog, and he thought that it was a comet. He noted that there was a comet that didn't move in the thigh of the dog, which is right where we're looking. and it does kind of look like a fuzzy comet. In fact, I hadn't mentioned it yet, but you might have noticed that I keep saying M78, M42, this is M41. That M stands for Messier. Charles Messier was an astronomer in the 1600s who was hunting for comets. And he kept spotting these little fuzzy patches that looked like comets, but unlike a comet, they didn't move in the night sky. They stayed in place. And so he knew that they weren't comets. And so he started making a list of these things and plotting their locations so that when he was searching for a comet and he saw it, he could say, nope, I already saw that. That's not a comet. And so in his list of not comets, he ended up making a list of some of the best and brightest deep sky objects in the night sky. And so as astronomers, we typically go out, and some of the first things that we look for and find are the Messier objects. And tonight specifically is certainly no exception. I'm taking you through several Messier objects, 5 to be exact, to get you started and show you a little sampling of some of the things that you can see. So go and check out M41, the open cluster. Let me know what kind of shapes you see, what you think about the stars that you see in it, and if you're able to find it. This is easily telescope or binocular visible. It's really nice in a telescope, but like I said, if you're in really dark skies, you can possibly even see it with your naked eye. Definitely with a telescope. I have no trouble even with small binoculars picking this out. Now, the last Messier object that we're going to hunt for is a little bit of a challenge, especially we've got a little bit of moon glow going, but I wanted to give you something that would challenge you a little bit with your telescope. And we're going to search for M1, the Crab Nebula. The Crab Nebula is actually in the constellation of Taurus. And I mentioned before, I'm going to step back here where we can see the ground in the whole sky. So we have Orion here. We've got Canis Major, the dog that we just looked at with Sirius. Over to the right, what you'll spot between Orion and the moon tonight is this V. And it's got a really orangey star over on the right side, Aldebaran. This is the constellation of Taurus. So we'll light Taurus up for you. So that little V forms his head, and his horns actually come all the way up, and you can see these 2 brighter stars right up at the end of the V. So you find this V and follow them up, and you'll see the 2 brighter stars that are the tips of his horns. I want you to look up at those and take your finder scope, and this tip of this left horn, what we're going to do is take our finder scope, and the way that I find this is I take this distance, and I want to go about 1/8 of the way from the left one towards the right one. So I divide it in half. That's half. Divide that in half again. That's 1/4. And then come again another half. That's 1/8. And then right on that line between them, I come just a little bit down towards the V. And that's where I put my finder scope. So center up your red dot or your finder, your crosshairs, or your tail rad right about there. And then pop in your eyepiece and have a look. And you should spot a little fuzzy little object right about there. Now, this is much fainter than the other things that we've been looking at, but this is the Crab Nebula. The Crab Nebula is actually formed, unlike the other nebula that we've been looking at, where we have nurseries and stars are being born. The Crab Nebula is actually from the death of a star. This is a supernova remnant. It was from an explosion. After the star ran out of fuel and it collapses upon itself, it blows up in a spectacular fashion. And we actually have records of this explosion. It happened in 1054, and Chinese astronomers took notes of it and mentioned that this guest star showed up in their sky, and they could see it in the daytime for 25 days. And then we're able to see it with the naked eye for almost 2 years. So this thing made a huge splash, and then after that was over, all of that gas that it spread out from its explosion is visible now, and it's still growing. It's spreading out constantly at about 1,500 kilometers per second, and it's about 6,300 light years away and about 6 arc minutes across. It's a little oval, so it's about 6 arc minutes one way and 4 arc minutes the other way. So this is very faint. And you'll want to take your time. If you have trouble seeing this and you know you're in the right area, because we just used our finder scope to place us just about a fourth of the way, you can see that's centered up right now, and so it's right about there. So once you know that you're in the right general area, one technique that you can use to spot these faint objects is what's called averted vision. So instead of looking right in the middle where you think it might be, take your eye and focus off to the side, and then try to notice what's over here, but be looking right here. That's called averted vision. And actually, the cones in our eye that are more sensitive to faint light are not in the middle of our vision. They're actually off to the side. So look over to the sides, and a little trick is that you can stare at one section and then stare over here and stare over here, because what we found is that for different people, your averted vision may work best in different areas of the sky. Like for me, if I stare right here in my 6 to 7 o'clock range of my averted vision, I can see faint things the easiest. So I always stare right about here to try to see something here. So this one's a challenge. It's faint and it's a little bit small, but it is worth taking a look at. It makes fantastic pictures. And once you spot it, you can zoom in with higher magnification, and sometimes that'll make the contrast step out. But this is actually best viewed in a really dark sky. So if you're doing this from your backyard in light pollution, you may not be able to find this. If you go out to a dark sky site, it should jump out at you because it's easy to spot in those conditions. A little bit harder in lower power binoculars. I don't see it as well with like an 8 power binocular, but I have no trouble finding it in my 15 power binoculars. So I'm really curious about M1. Let me know if you were able to see it, and if you were in your backyard or if you actually went out and went somewhere that was in a dark sky site. So that's it for the Messier objects tonight. I have one challenge object that I'm gonna send you guys looking for, and it's back in Orion. So when we light Mr. Orion up, you will notice that his club here has a little triangle. And what I want you to do is go over here where this little triangle is and put your finder scope just below and between the triangle. And then pop in your finder scope. Pop in your eyepiece and have a look. And there's a little star cluster in the middle there. And what's great about Stellarium is it's not giving away my surprise. So this is called NGC 2169. And I want you to find that star cluster for me. It's right there in the middle of that triangle. And if you find it, then let me know in the comments what you saw, because that cluster, take a look at it and see what shape it forms. It should jump right out at you as something that you would recognize. So if you find NGC 2169, let us know in the comments what you saw, what shape that cluster was, and we'll talk about that in the next show. Okay guys, that wraps up my first tour of the night sky. I hope that you go out and use it to find this stuff. Let me know in the comments if you were able to find this stuff. If you had trouble, let me know that too. And maybe we'll adjust how we do this as we go along. But I want to really help you to go out and find these cool things and get excited about astronomy like I am. So get those binoculars and get those telescopes outside and start looking up. And don't forget to subscribe to the page. When we hit 1,000 subscribers, I'm going to be giving away a Meade Polaris 130, just like I was simulating the view of with our program tonight. So that's really exciting. When we get to 1,000, I'll do a video, and we'll pick somebody randomly from the comments, and I'm going to give that thing away. So don't forget to like, subscribe, ring the bell, leave me some comments, let me know what you found, and I'll see you next time.